Bismillahirrahmanirrahim. Assalamu alaikum viewers. In my previous video, I have learned you about the position vector, direction cosines of a vector, vectors, null vector, unit vector, and hopefully the all students will be able to find and learn about the concepts of unit vector, null vector, position vector, etc. In my recent video and in my present video I am going to discuss about the spherical polar coordinate and I will start by the definition of the spherical polar coordinates by the BSc mechanics by Resnick. This is an important topic of BSc mechanics and often it comes in the papers of the Punjab University. The coordinate system, I am going to discuss about the definition of spherical polar coordinates, and this is like that: the coordinate system for three-dimensional space in which position of a point is specified by the three numbers such as the radial distance rho, polar angle theta and azimuthal angle phi is called spherical polar coordinates. It's mean that I am talking about the three-dimensional space. Three-dimensional space is the space in which we have a plane like XYZ, and in this plane we have three numbers. The new thing is that there are three numbers which are radial distance rho, polar angle theta and the azimuthal angle phi. These are the three terms which are new for us, and I will discuss in the next video about these three terms with the definition. Now you know about the position vector, that the vector which is used to locate the position of a body in the plane. And the spherical polar coordinates do the same work, and the difference is only of the number, that is rho, theta and phi. Now the work is same, that it only find the position of a point in the specified region. Now I will discuss about the this was the concept of this definition of a spherical polar coordinates. Now I will find the relation between the Cartesian coordinates and the spherical polar coordinates. It's mean I am going to discuss about the relation between the Cartesian coordinates and spherical polar coordinates. Consider point P in the XYZ plane. First of all, what we have to do, in we will take XYZ plane as you can see in the figure, and this is also called the reference frame because it have a region O, and you know that the line, and you can see the points. First of all I will discuss about the points, that is you can see, I'm sorry, you can see that is O Z, that is I think so I should mark it O Z, yeah, I think so, again O Z Y X. These are some points which you have to recognize about it. Now the line OX is called initial line. It is saying that the line OX, you can see in the figure the line OX, obviously that is initial line, that is called O, and this is X, O to X. I'm sorry, it is disturbed. OX is called polar X initial line, sorry, initial line. OX is called initial line. Now we will see next line, which is OZ. It is discussing about OZ. You should see in the figure OZ, where is OZ, and you will find that OZ is called the polar axis, which is perpendicular on the polar plane. It means it's perpendicular on the polar plane. And what is polar plane? Where is polar plane? OY. It doesn't tell us, but OY is basically called the polar plane. It's okay. OY is called the polar plane, yeah, and I will discuss again it. The line OP is equal to rho, and the polar plane, the line OP is equal to rho. You know that the line OP, and now you can see in the figure that the line OP is shown. Here the important point which is used to which you have to I have to discuss, that is rho, theta and phi. The point P is consists of three numbers, that is P, rho, theta and phi, and these are the spherical polar coordinates. Otherwise, the Cartesian coordinate, that is that are x, y, and z, and P is consist of these three numbers x, y, and z, but in the Cartesian coordinate. So this is the difference between the polar and the Cartesian coordinate. The line OP is equal to rho. Now he is saying that the line OP is equal to rho. It's mean that is it's saying that the first number, that is rho, is equal to OP. Now, the angle between OP and OZ is phi. The next one is the line OP and OZ. I am discussing about the line OP and OZ is phi, and you can see the OP and OZ hopefully, and the OP and OZ have the same angle, that is phi, only phi. I have to say that this is phi. It's okay. Now next, the projection of OP on the polar plane is OQ. Projection, it's mean the you can say the shadow. The shadow of OP on the polar plane is OQ. Polar plane has the shadow of OQ. You can say like that. It's mean OP and OQ both should have the shadow of each other. It's okay. You can see in the figure, you can just pause the video and you can see OP and OQ if you don't recognize. Next, line OQ is parallel to PZ. Line OQ, where is OQ? This is OQ. This is OQ. It's okay. OQ is parallel to PZ. PZK. It's mean it's PZ. P and Z. This is PZ, rho sine phi. Where is rho sine phi? Rho sine phi is showing PZ. OQ is parallel to PZ, equal in magnitude. Magnitude is same for those of these numbers. Now next, the angle OQ with initial reference line OX is theta. Next is this one, that about the angle OQ. Where is OQ? OQ is like that. You can see in the figure that OQ, where is OQ? This is here. OQ. It's okay. OQ, the angle OQ with initial reference line OX is theta, and we can see the angle theta here, which is here. I can indicate it hopefully. Now coordinate rho, theta, phi are called the spherical polar coordinate of a point P. It's mean that we are able to find the coordinates, that is rho, theta and phi. These are called the polar coordinate of point P. Basically we have to tell about these three numbers, that is rho, theta and phi. These are very important. From figure, you can see from figure, that is PZ. I'm sorry, but here, that is PZ. PZ is equal to rho sine phi. PZ, you can see here PZ. Where is PZ? PZ is PZ. PZ, you can see that PZ is equal to rho sine phi. Similarly, OZ is equal to rho cos phi. So PZ is equal to rho sine phi, OZ is equal to rho cos phi, PZ is equal to OQ, and OQ is equal to rho sine phi. So resolve OQ into two components. Now I will resolve OQ into two components. PZ is equal to OQA, then we can say that OQ is equal to rho sine phi. By the figure, OQ is equal to rho sine phi. You can see OQ is equal to rho sine phi. Now resolve OQ into two components, that is x is equal to rho cos phi, rho cos theta sin phi, and y is equal to rho sin theta sin phi. These are very important components. And the third one is z is equal to rho cos phi. These three components are the basic and the keywords of this spherical polar coordinate. This is also used as a formula in our numerical values, and you will face problems related to spherical polar coordinate and can solve it by these three terms, that is x, y and z. So these are the relation between the spherical polar coordinate and the Cartesian coordinate. And if you find any query in this topic, you can comment me in the comment box, and you can share your problems about the topic of physics, and you can also share everything about physics problem numerically to me in the comment box. Thank you. Thank you so much.